Alright guys, today we're going to talk about the special right triangles that we did in the last couple videos. That's the 30, 60, 90 and 45, 45, 90 triangles. But these are special because the hypotenuse is 1 unit. This is what's going to tie your geometry trig to the Algebra 2 part of trig. So let's take a look here at this 30, 60, 90 triangle. This is my 90-degree angle. Here's 30 and here's 60. So what I've been given is the hypotenuse. Well, it is 1 unit. Well, remember, the short leg of your 30, 60, 90 triangle is equal to 1/2 of the hypotenuse. So the length of this short leg is 1/2. The long leg is equal to the short leg times the square root of 3. So I'm going to write 1/2 times the square root of 3 and then simplify it. Go ahead and multiply your 1/2 times the square root of 3 will give me the square root of 3 over 2. So here's my long leg, here's the short leg. For 30, 60, 90 triangles, remember, we've got our A, our 2A, and our A square root of 3. Those are the patterns we used last time. And now over here for the 45, 45, 90, remember, the two legs are congruent. They are both A, and your hypotenuse is supposed to be A square root of 2. Well, my hypotenuse doesn't have a square root on it. So remember, our shortcut for getting the legs when the hypotenuse does not have a square root of 2, here's what we do. We take the hypotenuse, divide by 2, and attach a square root of 2. And then we need to go ahead and simplify that by multiplying, and I end up with square root of 2 over 2 for this leg. In a 45, 45, 90, the two legs are congruent, so this one is also square root of 2 over 2. These values for 45, 45, 90, square root of 2 over 2, square root of 2 over 2, and these values for the short leg and the long leg of the 30, 60, 90, 1/2 and square root of 3 over 2 are going to be very, very important in the next couple of lessons. All right, we've also got to deal a little bit with the Pythagorean theorem. Remember, it is a squared plus b squared equals c squared. Your hypotenuse always goes here. The two legs are A and B, and it doesn't matter which one goes where. Here's what we need the Pythagorean theorem for. It will help you find the third side of any right triangle when you are given two sides. It doesn't have to be one of the 45, 45, 90s or 30, 60, 90s, but it could be. So here is my right angle. And in the first problem, they tell me that A is equal to 3, B is equal to 4. I'm supposed to find C. So when I plug into my Pythagorean theorem, I have 3 squared plus 4 squared equals C squared. And where we go from there is go ahead and square the 3 and the 4. So you get 9 plus 16 equals C squared. Combine your 9 and 16, so you get 25 equals C squared. And that gives me 5 is equal to C. Technically it's plus or minus 5, but since we're talking about the length of a side of a triangle, it has to be positive. So for this problem, C is equal to 5. All right, for problem number 2, I know A and C, but I don't know B. So let's plug in what we know. I've got 5 squared plus b squared is 13 squared. Now, let's go ahead and square those. So I get 25 plus b squared equals 169. And now I have to get b squared by itself. So I'm just going to subtract 25 from both sides. And I get b squared equals 144. Now, square root of both sides will give me b equals 12. And again, this is technically plus or minus 12, but it's the length of a side of a triangle, so it has to be positive. So b equals 12. And now for number 3, I have a is 4, plug it in. I'm looking for b, and c is 8. Go ahead and plug that in. And now go ahead and square those. So I end up with 16 plus b squared is 64. And then I want to subtract my 16 from both sides. So when I do 64 minus 16, I get 48. So b squared equals 48. Take the square root of both sides, and b is equal to the square root of 48, but that can be simplified. It will break down into the square root of 16 times 3. Square root of 16 is 4, so it goes outside, the 3 stays in. So b is equal to 4 square root of 3 in this problem. Okay, we're not going to get a decimal value. They didn't tell us anything about rounding, so we're just going to leave it in simplified radical form. All right, next, we're going to review sine, cosine, and tangent. Now, things look just a little bit different here in Algebra 2 than it did in geometry. In geometry, you always had letters, an A, a B, and a C on the vertices. And sometimes in Algebra 2, you'll still have those as well. But instead of talking about the sine of angle A, we're going to talk about the sine of theta. Okay? This symbol right here is a theta symbol. Theta is a Greek letter used to represent an angle. The other thing here is your review for sine, cosine, and tangent. I always teach this using SOH, SOH. That is for sine, cosine, and tangent, can be used to find the missing parts of a right triangle. And here's how. The S in sine, the O in opposite, the H in hypotenuse. That's where the SOH in SOH comes from. The sine of theta is equal to opposite over hypotenuse. Your cosine, there's your C, the A in adjacent, the H in hypotenuse. That is the CAH in SOH. So your cosine of theta is equal to the adjacent side over the hypotenuse. And for tangent, take the T, the O in opposite, the A in adjacent. That's where the TOA in SOH comes from. So tangent of theta is equal to the opposite side over the adjacent side. So let's take a look at this triangle above. Here is my theta. Regardless of where that theta is at, it will always be in one of the acute angles. But regardless of which one it is, your hypotenuse is always across from 90. So this is my hypotenuse. Now, based on where this theta is, this 5 is all the way on the opposite side of the triangle from my theta. So this is going to be the opposite side, which means this one has to be the adjacent side. Okay, adjacent means next to. So adjacent, we're going to look for the side that is next to the theta, but it can't be the hypotenuse. This is going to be your adjacent side. So if I were to write the sine of theta for this problem, I need the opposite over the hypotenuse. So the opposite side is 5, the hypotenuse is 13, and we're going to leave it just like that. Cosine theta is the adjacent over the hypotenuse. Well, my adjacent side is 12, and the hypotenuse is 13. So we'll put 12 over 13. And then the tangent of theta is the opposite side over the adjacent side. So that will make it 5 over 12. And you leave it. We're done right there. So now I've got one at the bottom for you to try. But before I send you off to work on it on your own, let's take a look. We're missing a side over here. I need to know how long that side is. So how do we find the missing side of a right triangle when we are given two sides? Well, we have to use the Pythagorean theorem. So a squared plus b squared is equal to c squared. And remember, your hypotenuse is always c. So my hypotenuse is 10. That means this 6 is either a or b, and it doesn't matter which one. So I'm going to substitute it for a. So I'm going to have 6 squared plus b squared equals 10 squared. And to solve the Pythagorean theorem, let's go ahead and square those. Subtract my 36 from both sides. B squared is 64. And now take the square root of both sides. And b is technically plus or minus 8, but again, it's the side of a triangle, so it has to be positive. So now I know all three sides. Now I have to figure out, based on this angle theta, which one is opposite, which one is adjacent, and which one is hypotenuse. Remember, your hypotenuse is always across from 90. So there's that one. Now, from this theta, all the way across on the opposite side of the triangle is my 6. So this is opposite, meaning this one, therefore, has to be the adjacent. It is next to this angle, and it's not the hypotenuse, so it is the adjacent. So now that we've got our triangle labeled here, and you know which one is opposite, adjacent, and hypotenuse, I need you to go ahead and complete these. Okay, you may need to pause the video for just a minute till you get that done. I'll go ahead and put mine up here. Make sure that you reduce your fractions. Fractions should always be given in simplest form, which means reduce them. All right, so sine is opposite over hypotenuse. So I'm going to put 6 over 10, reduce that to be 3 over 5. Cosine is adjacent over hypotenuse. So 8 over 10, reduce that, means the cosine of theta is 4 over 5. And the tangent is opposite over adjacent. So 6 over 8 reduced gives me 3 over 4. Alright, so now I've got one for you to try. Alright, so once again, you've got to find the missing side of the triangle. And then you're going to have to find sine, cosine, and tangent for this triangle. So you may need to pause for just a second while I work on it here, and then you can unpause it and check your answers with mine. Let's try that one again. I can't seem to write the right thing on my paper. Tangent is opposite over adjacent, not a hypotenuse. So opposite over adjacent makes it 24 over 7. So check it. If you have questions, let me know the next time I see you. All right, so now the last thing for today are 3 new trig identities. Now, this CSC, that is pronounced as cosecant. Okay, it's just an abbreviation. CSC is for cosecant. Well, cosecant is equal to 1 over the sine, or you may think of it as hypotenuse over opposite, which just means take the answer for your sine and flip it upside down. So the secant of theta, SEC, stands for secant. It is equal to 1 over the cosine, or think of it as hypotenuse over adjacent, which is just your cosine flipped upside down. And COT, that is not cot, that is cotangent. It is equal to 1 over the tangent, or you can think of it as adjacent over opposite, which basically is just tangent flipped upside down. So now what we want to do is we want to find the value for these 3 new trig functions for the problem we did at the top of the page. So I want the cosecant of theta. Well, remember, cosecant is your sine flipped. So at the top of the page, my sine was 24 over 25. Let's make this smaller so we can see the top maybe. There we go. The sine was 24 over 25, so when I flip that, my cosecant is 25 over 24. Your secant is your cosine flipped. So if I take 7 over 25 and flip it, I get 25 over 7. And cotangent is tangent flipped. So if I take 24 over 7 and flip it, I get 7 over 24. So that does it for the geometry, trig, and special right triangle review. We also introduced 3 new trig functions. All right. The next videos after this deal with the Algebra 2 part of trig.